The James Webb Space Telescope has given scientists and even people like you and me chasing a beautiful and mesmerizing image of a planet, the clearest images of space that we have ever captured before. The telescope was first proposed as a far more advanced successor to the Hubble telescope in the 1980s, but serious planning began in the early 1990s. Early development began in 2003, and a launch date was set for 2010, but with gross mismanagement, the telescope was approximately $10 billion over budget and 11 years late on the proposed launch date. Webb uses infrared light, which cannot be perceived by the human eye, to study every phase in cosmic history. The telescope's 4 scientific instruments are specifically designed to capture infrared light and are able to peer through cosmic dust to study colder or very distant objects. Infrared astronomy is a branch of astronomy that focuses on observing and investigating celestial objects using infrared radiation. Infrared light has a wavelength of 0.75 to 300 micrometers, which lies between visible radiation and sub-millimeter waves. Infrared astronomy began in the 1830s, only a few decades after William Herschel discovered infrared light around 1800. Early development was slow, and it wasn't until the early 20th century that conclusive detections of celestial objects other than the sun and moon in infrared light were made. Following a series of radio astronomy discoveries in the 1950s and 1960s, astronomers discovered the information accessible beyond the visible wavelength range, and modern infrared astronomy was born. Because the same mirrors or lenses are frequently effective throughout a wavelength range that encompasses both visible and infrared light, infrared and optical astronomy are often conducted using the same telescopes. Both sectors employ solid-state detectors, albeit the precise types of solid-state photodetectors employed different. Because water vapor in the Earth's atmosphere absorbs infrared light at many wavelengths, most infrared telescopes are located at high altitudes in dry areas, above as much of the atmosphere as possible. Infrared observatories in space have also existed, notably the Spitzer Space Telescope, the Herschel Space Observatory, and most recently, the James Webb Space Telescope. The U.S. National Aeronautics and Space Administration led James Webb Space Telescope's development in collaboration with the European Space Agency and the Canadian Space Agency. The NASA Goddard Space Flight Center in Maryland oversaw telescope construction. The Space Telescope Science Institute on Johns Hopkins University's Homewood campus in Baltimore manages James Webb Space Telescope, and Northrop Grumman was the prime contractor. The telescope is named after NASA Administrator James E. Webb, who served from 1961 to 1968 during the Mercury, Gemini, and Apollo projects. The James Webb Space Telescope's primary mirror is made out of 18 hexagonal mirror segments constructed of gold-plated beryllium that comes together to form a 6.5-meter diameter, 21-foot mirror, compared to Hubble's 2.5-meter. James Webb Space Telescope has a light-collecting area of around 25 square meters, which is roughly 6 times that of Hubble. Unlike Hubble, which observes in the near ultraviolet, invisible, and near-infrared spectra, James Webb Space Telescope observes in a low-frequency range, ranging from low-wavelength visible light to mid-infrared. The telescope must be maintained extremely cold, at temperatures below 223 Celsius, so that the infrared radiation generated by the telescope does not interfere with the gathering light. It is placed in a solar orbit at the Sun-to-Earth L2 Lagrange point, approximately 1.5 million kilometers from Earth, where its 5-layer sunshield shields it from heating from the Sun, Earth, and Moon. The James Webb Telescope is considered a huge step in modern astronomy, as it will study anything from newborn stars to astronomical abnormalities by sensing infrared radiation. The James Webb Space Telescope is proven to be the most sensitive telescope yet for detecting infrared cosmic radiation, wavelength just longer than those which humans can see. Astronomers are intrigued by this type of radiation for 3 reasons. In the beginning, it penetrates dust clouds more effectively than visible light, exposing previously undiscovered areas where stars and solar systems are developing. Second, it is given off by old hot objects like galaxies and stars, whose wavelengths have been pushed into the infrared by the expansion of the universe. Thirdly, it also fits with the emissions of cool objects like planets, especially ones that support life. The capacity of the telescope to detect infrared is expected to bring about a revolution in astronomy. The earliest stars and galaxies, which originated just a few 100 million years after the Big Bang, will be visible to the James Webb Space Telescope. Additionally, it will be able to discover faraway planets by both directly measuring their heat and by observing how their host star's brightness changes when circling planets pass in front of them. These transit investigations will illuminate the makeup of planetary atmospheres, indicating where water is found in the cosmos, and maybe how it got there. The planets nearest to Earth will become less mysterious as a result of all this. Astronomers have a wealth of knowledge about the solar system, but there is not enough information from other systems to draw meaningful comparisons about what is common and uncommon. That will alter with the James Webb Space Telescope. Additionally, it will offer fresh viewpoints of neighboring worlds. The intensity of the sun prevents imaging of Mercury and Venus, but other planets, along with their possibly habitable moons, will have their atmospheres and geology thoroughly examined. So much for the claimed scientific goals of the trip. Other tempting fruit will undoubtedly be included in the data harvest. According to astronomers, all of these galaxies, stars, and planets, including our own, account for barely 5% of the universe's matter. The dark elements that make up the remainder are anticipated to receive some illumination from the James Webb Space Telescope. The so-called dark matter, which has mass, but whose basic composition is still unknown, make up around 27% of the universe. The remaining 68% is made up of dark energy, which accelerates the universe's expansion, but whose exact mode of action is currently unknown. Add in some insights into the universe's early black holes and mysterious fast radio bursts, strong flashes of radiation lasting only 1,000th of a second, and the James Webb Space Telescope promises to address some of the phenomena that keep astronomers up at night. And, as with any scientific device representing such a jump in capabilities, some of the most intriguing outcomes will be other surprises. According to Christine McQuinn, an astronomer at Rutgers University in New Jersey, it's probable we'll make findings regarding issues we don't even know to ask now. The James Webb Space Telescope was approximately $10 billion over budget, and 11 years later, when it was finally launched on Christmas Day of 2021. Mismanagement allegations have put the project, a partnership involving the space agencies of North America, Europe, and Canada, in jeopardy. However, when the first photographs were sent back to Earth, experts were certain that everything would be forgotten. So far, the magnificent images have proven their faith to be well-founded. The first images that the James Webb Space Telescope have taken are notably more accurate, vivid, and all in all, more beautiful than the previous scientific space telescopes, such as Hubble. As we experienced in the previous decades, technological development is happening at a speed never seen before. But the improvement of computers is not only for the entertainment of everyday people. NASA's new innovations shed light on how we have progressed as a species on a huge scale. We should really look around and see not only how our life is affected by this technological revolution, but how humanity is getting closer to venturing out and exploring faraway places, getting to know our universe and all sensations it has. To keep up to date with news about technologies never seen before, subscribe to our channel and like the video so everyone can see how far we've come. Thank you all for watching.